Hi, welcome back to my class in Calculus 3. For today, we will take up the graphs of polar coordinates. And we start with this graph known as the Archimedean spiral. In general, the polar equation of an Archimedean spiral is R equals A multiplied by B, where B is the angular coordinate of a point on the graph and R is the radial coordinate. And the angle B must be in radians and A is a real number. This particular Archimedean spiral shown in the graph has polar equation R equals 1 half B, where A is 1 half and B is the angle in radian measure. There are two Archimedean spirals shown in this graph. The smaller or tighter one and the larger or the wider spiral. But both of these Archimedean spirals start from the origin representing the point with polar coordinates 0, 0, where the angle B is 0, and when the angle B is 0, the radial coordinate R is also 0. Again, in general, the polar equation of Archimedean spiral is given by R equals AB, where A is a real number and B is the angle in angular coordinate in radians. In particular, the smaller spiral shown in the graph has polar equation R equals 0.1 B, where the real number A is equal to 0.1. The wider or larger Archimedean spiral has polar equation R equals B. And the value of A in the polar equation of the tighter spiral is 0.1 is less than or is smaller than the value of A, which is 1, in the polar equation of the wider or the larger Archimedean spiral. In general, the smaller the value of A in polar equation R equals AB, the tighter is the Archimedean spiral. And the larger the value of A in the polar equation R equals AB of the Archimedean spiral, the wider is the Archimedean spiral. Next, we take another set of graphs of polar equations. The polar equations whose graphs are circles. The circle that is symmetric with the y-axis or the vertical axis shown in the graph has equation R equals A sine B. In particular, for that circle symmetric with the y-axis, the value of A is equal to 2. So in general, a polar equation of the form R equals A sine B, the graph is a circle passing through the origin and symmetric with the y-axis or vertical axis, and the diameter of the circle with polar equation R equals A sine B is equal to A. Now consider the circle shown in the graph passing through the origin or the point 0, 0 and symmetric with the horizontal axis. This circle has polar equation of the form R equals A cosine B. In particular, the circle shown in the graph has polar equation r equals 2 cosine b. In general, the polar equation of the form r equals a cosine b is a circle passing through the origin and symmetric with the horizontal axis with diameter of a. The next set of graphs of polar equations is known as the roses. Roses have polar equations either of the form r equals a sine nb or r equals a cosine nb. In both polar equations, a is a real number, n is a positive integer, that is, n is a counting number, and b is the angular measure in radians. In particular, the purple rose with 4 petals has polar equation r equals cosine 2b, where a is 1 and n is 2. While the green rose with also 4 petals has polar equation r equals sine 2b, where a is 1 and n is also equal to 2b. N is also equal to 2. In general, the graph of polar equations r equals a sine nb and r equals a cosine nb are both roses. And the roses have the same appearance, except that in the particular examples of polar equations whose graphs are roses, the graph of the polar equation r equals sine 2b can be obtained from the graph of the polar equation r equals cosine 2b by rotating the graph of the polar equation r equals cosine 2b 45 degrees counterclockwise or clockwise, and the result is the rose, that is the graph of the polar equation r equals sine 2b. Now we investigate the relation between n and the number of petals in the graph of the polar equations r equals a sine nb and r equals a cosine nb by fixing the value of a at 2. Again, the polar equation of a rose or roses is either r equals a sine nb or r equals a cosine nb. And we fix now the value of a to 2, that is a equals 2. And we find the relation between the value of n, the positive integer n, and the number of petals in the rose, that is the graph of the polar equation r equals a sine nb or r equals a cosine nb. We fix the value of a at 2 and we vary the value of n. And the initial value of n is 2. If a is 2 and n is 2, the polar equation r equals a cosine nb becomes r equals 2 cosine 2b. And the graph of that polar equation is shown in the graph in the diagram with 4 petals. the graph of R equals A cosine 2B is a rose with 4 petals. And the number of petals equals 4. And 4 is divisible by 2. It can be written as 2 multiplied by 2. But n is equal to 2. Therefore, the number of petals in the graph of the polar equation R equals to cosine 2B is 4, which is equal to 2 multiplied by 2 equals 2 multiplied by n, where n is the positive integer we assign to n, which is 2. With a fixed at 2, we now change the value of n to 3, and we investigate the number of petals in the graph of the polar equation with n equals 3. Earlier, we set n equals 2. Now, for the same value of a equals 2, we now take n equals 3. And the polar equation R equals A sine NB, for A is 2 and n is 3, becomes the polar equation R equals 2 sine 3B, which in the graph is 2 sine 3 theta, where theta is B. And the graph of this polar equation R equals 2 sine 3B is shown in the diagram, which is a rose with 3 petals. And the number of petals 3 is equal to the value of n 3. Combining the result earlier and the result now, for the same value of A equals 2, if n is 2, which is even, we have seen that the graph of the polar equation is a rose with 4 petals. But for n equals 3, which is an odd number, the number of petals in the graph of the polar equation is equal to the value of n, an odd number. In the same polar equation, R equals A sine NB, we take A as 2 because A is fixed, but now we let n be equal to 4. And the polar equation R equals A times sine NB becomes R equals 2 multiplied by sine 4b, which in the graph is the equation R equals 2 sine 4 theta, where theta is the angle B. And the graph of the polar equation R equals 2 sine 4b or 4 theta is a rose with 8 petals. The number of petals 8 is equal to 2. 8 is again even number divisible by 2, hence 8 is equal to 2 multiplied by 4. But 4 is the value of n. So the number of petals for n equals 4. 8 can be written in terms of n as 2 multiplied by n, where n is 4. We have seen that in polar equation R equals A sine NB, or the polar equation R equals A cosine NB, the graph is a rose, and if n is an odd number, the number of petals in the rose is n. If n is an even number, the number of petals is twice the value of n, which is even number. Consider the polar equation R equals A sine NB. We now fix the value of n at n equals 4, and we will assign values to A. For A equals 1 and n is 4, the polar equation is R equals sine 4b. In the diagram, there are actually 3 roses that represent the 3 polar equations. And the smallest of the 3 roses has polar equation R equals sine 4b. And since n is equal to 4, the number of petals in the rose is twice the value of n, which is 4, and that gives us 8. Hence, the graph of the polar equation R equals sine 4b for A is 1, and n is 4 is a rose with 8 petals. We now increase the value of A from 1 to 2. And the polar equation R equals A sine NB becomes the polar equation R equals 2 sine 4b, where A is 2 and N is still 4. Again, the graph of this polar equation is a rose with 8 petals. Because n is even, the number of petals of the rose is twice the value of n, an even number, and is equal to 4. Thus, the rose representing the polar equation R equals to sine 4b has 8 petals. And the difference of this rose from the rose with polar equation R equals sine 4b is that the leaf of the rose for the polar equation R equals to sine 4b is longer. We assign a third value to A, which is now 3, and the polar equation R equals A sine NB, where n is still 4, is now the polar equation R equals 3 sine 4b. Since n4 is even numbered, the graph of this polar equation R equals 3 sine 4b is a rose with twice the value of n petals, and n is 4 multiplied by 2 is 8. Hence, the graph of the polar equation R equals 3 sine 4b is a rose with 8 petals. And the leaf of this rose is longer than the leaf of the rose represented by the polar equation R equals 2 sine 4b. We have seen that if the value of n remains constant or fixed and the value of A varies, the length of the leaf of the rose differ, and the length of the leaf of the rose, the length of the petal of the rose is represented by the value of A. Thus, in polar equation R equals A sine NB, the significance of A is that the larger the value of A, the longer is the length of the petal of the rose, represented by the polar equation R equals A sine NB. Another set of graphs of polar equations is known as the set of limacons. Polar equations of the following forms have limacons as graphs. The polar equation R equals A plus B sine B is a limacon. The polar equation R equals A minus B sine B is a limacon. The polar equation R equals A plus B cosine B is a limacon. And the polar equation R equals A minus B cosine B is also a limacon. Some limacons are given special names depending on the values of A and B. The graph shown in the diagram represents the graph of a polar equation R equals 2 plus 3 sine B. And the graph of this polar equation is a limacon, as shown in the diagram. For the polar equation R equals 2 plus 3 sine B, the value of A is 2 and the value of B is 3. That is, A is less than B. If the value of A is less than the value of B in the polar equation, the graph is a limacon and the limacon has a loop as shown in the diagram, which is the graph of the polar equation R equals 2 plus 3 sine B, where A is 2 and B is 3 and A is less than B. In general, if in any of the four polar equations R equals A plus B sine B, R equals A minus B sine B, R equals A plus B cosine B, or A equals A minus B cosine B, the value of A is less than B, the graph is a limacon with an inner loop. And an example is the polar equation 2 plus 3 sine B. The graph of that polar equation is a limacon with inner loop because A is less than B. Specifically, 2 is less than 3. Another example of a limacon is the graph shown in the diagram. As you can see, the limacon has no loop, and this limacon shown in the diagram has polar equation R equals 5 plus 4 cosine B, where the value of small a is 5 and the value of small b is 4. And you can see that the value of a, 5, is greater than the value of b, 4. In general, if in the polar equation, the value of A is greater than the value of B, the limacon is called dimpled limacon. The limacon has no loop, but the limacon is said to have a dimple. This graph is another example of a limacon, but this particular limacon has no loop and it has no dimple and it is not a circle. The polar equation of this limacon is given by R equals 5 minus 2 sine B. For that polar equation, the value of small a is 5, the value of small b is 2, And we calculate the value of 2b, or twice b, twice the value of b, or 2 times b, which is equal to 4. And you can see that a is greater than 2b, which is 4. 5 is greater than 4. If in the given polar equation, the value of a is either greater than 2b or is exactly equal to 2b, the graph of the polar equation is a limacon, and in particular, it is called convex limacon. This graph is also a limacon. And the polar equation of this graph is given by r equals 2 minus 2 sine b. For this polar equation, the value of a is 2 and the value of b is also 2. So the values of a and b are equal. If in the polar equation, the value of a and b are equal, the limacon is called a cardioid. Similar to this graph would be the graph of the polar equation r squared equals a squared multiplied by cosine 2b, or the graph of polar equation r squared equals a squared multiplied by sine 2b. This graph is what is known or what is called as the lemniscates, similar to the infinity sign. This particular graph represents the polar equation r squared equals 9 cosine 2b. The graphs of some polar equations are lines, such as the graph shown in this diagram. This line has polar equation given by r equals 1 over sine b minus cosine b. And it is easier to find the Cartesian equation of this line using the identities for x and y. From x equals r multiplied by cosine b, we get the value of cosine b by dividing both sides of x equals r cosine b by r. Thus, cosine b equals x over r. Similarly, from y equals r multiplied by sine b, we solve for sine b by dividing both sides of y equals r sine b by r. Hence, we get sine b equals y over r. In the polar equation of the line, we replace sine b with y over r, and cosine b we replace with x over r. The polar equation of the line earlier is given by r equals 1 over sine theta minus cosine theta. And we now replace sine theta with y over r and cosine theta with x over r. In the denominator, we have y over r minus x over r, and the common denominator is r. Thus, we simplify the complex fraction 1 over y minus x over r. by multiplying 1 by the reciprocal of y minus x over r. And we get r over y minus x. And multiplying y minus x by r, we get r times quantity y minus x equals r. And dividing both sides by r, we get the equation of the line in terms of the variables x and y. And the equation of the line is y minus x equals 1. And this is called the Cartesian equation of the line in terms of the variables x and y. This graph is called the conchoid of Nicomedes. And the polar equation of this graph, or the polar equation of the conchoid of Nicomedes, is given by r equals 8 plus 3 multiplied by cosecant theta, where theta is in radians. The polar equation of this graph shown in the diagram is given by r equals sine theta plus the cube of sine of 5 and theta over 2, or the cube of sine of 10 plus theta over 2. And that particular graph is not given a title or a name. This graph is known as the hyperbolic spiral. And the polar equation of the hyperbolic spiral is given by r equals 1 over theta. The polar equation of this graph is given by r equals 4 multiplied by cosine of half of theta. And this graph is not also given a title or a name. The polar equation of this graph is given by r equals the squared of cosine 5 theta plus sine 3 theta plus 0.3. And this graph is known as Oscar's butterfly. That completes our lesson on graphs of polar equations. Thank you for joining me in my class today in Calculus 3.